on an island.
It's been a few months laid off since our 2024 lecture series, so it's my job to welcome all of you to the 2025 lecture series. And it's my privilege to introduce Richard Dillman, who's the president of the Maritime Radio Historical Society, and he's going to talk about the history of that, of maritime radio and service. Will you join me in welcoming?
Thanks so much, and also Elizabeth for arranging to have the time here. I attended many lectures here, never really pictured standing up in front of everyone, but we got a lot to cover, and before we plunge in on that, there's two things that we really need to get straight among us. We're talking about the radio sites here in West Marin, and the things that we have to keep in mind is there were two things going on at those radio sites. One was the ship-to-shore transmission, the Morse code, the kind of thing that the Titanic used, where the SOSs were sent. That's what the Maritime Radio Historical Society has restored and brought back to operation. The first time that's ever been done with the hundreds of these stations that used to exist around the world, and maybe at another time we'll get to talk about this. The thing that we're talking about today goes back a little bit further in time as it existed here in West Marin, and that is Marconi's business plan of spanning the oceans for intercontinental communications. No ships involved, city to city across the oceans. That's what we are going to be talking about today. And the other thing that we need to keep in mind is what we're really talking about is magic. That's really what it is. It's a strange thing for a radio engineer like me to say, because I'm the engineer at the transmitter sites for KWMR, our local station, and for the civilian first responders radio system. We're obsessed with radio, everything radio, that's me. So it's a strange thing to say, you know, it's magic, because I know if I consult the manuals and I do the calculations and I assemble things, I know it's going to work. But how it works, nobody really knows. And you know, a lot of us won't admit that, but that is really the truth. In fact, it's almost like our little planet, which has just the right distance from the sun, and just the right temperature, and just the right composition of gases in the atmosphere, and just the amount of water, and just the amount of dry land to allow life to exist on the planet. It's almost like it was created in that way to allow these radio and wireless communications to exist. And we'll talk about a little bit about that as well as many other things. I've been studying this for a long time, but there are folks in the audience who may know more than I do, so I'm sure they do, and maybe help fill in the gap when we get to the question and answer period, and certainly look forward to that. We assembled a lot of photographs, many of which haven't been seen very much publicly. So let's just get started on that. Let's just jump right in. And this is Heinrich Hertz. This guy is German. He's working in his laboratory. He's seeing some things taking place that seem to confirm James Clerk Maxwell's equations, which predict these electromagnetic waves. Complete mystery, don't really understand this, but he sees that these phenomena are happening in his laboratory. And what he sees is that by this time, the technology had evolved to the point where you could actually generate continuous spark. It's not like going across the carpet and you zap on the doorknob or something like that. This was continuous. So you see he's got his batteries there, and he's got his induction coil, and he's got a spark going, and here he is standing across the room, and he's got this loop, and every time the sparks jump across his spark gap here, a spark gap jumps across the loop that he's holding in his hand. How can this be? There's nothing between those two events, those two facilities, those two pieces of apparatus. Obviously something is going on here. They're not really sure about it, but that's part of science, that's part of experimentation. He sees this, what does this really mean? And you may recognize his name, Hertz, because we talk about kilohertz and megahertz these days, so it's named after him in honor of the work he did. But for a large part of his time, it just remained a laboratory curiosity. People would investigate it, how far can you go, how big can the gap be, things like that. It really took Marconi, here he is as a young man, to start to bring these things together. There was, needless to say, some time of development and more knowledge, but he became really interested in this. And inventor of radio? Absolutely not. And he admits that, he doesn't claim to be. He does admit, with no problem, that he used various discoveries by various people, although he himself did come up with several seminal inventions that really allowed the advancement of the art. But he always said, yes, building on the shoulders of what other people had done. But he basically took it out of the laboratory, and his great scheme was, this can be a commercially viable technology. Nobody ever really thought of it that way before. Luckily, here's one of his very early apparatus, and you see, he really was trying to be a very, very serious young man. Never smiles. We've got hundreds of photographs of him. No smiling. He's trying to be he wants to be taken seriously. And luckily his family has some wealth in Bologna. He's got an estate, his father's estate, that's where he's living. And here he's experimenting with some of the early apparatus that he came up with. And you see here some of the early things that evolved later. There's this plate here, and that's his first antenna, one of his early antennas. Now, he wasn't a scientist, he wasn't an engineer, and thank goodness he wasn't, because all the scientists, all the engineers are telling him, hey, what's the matter with you, nice Italian boy? Everybody knows that radio waves, these Hertzian waves, these electromagnetic waves, everybody knows that they don't go over the horizon. So why are you messing with this stuff? This is a laboratory thing. I don't know why you're playing with this. But he knows, as he experiments further, and he gets 1,000 feet, he gets a mile, he gets 10 miles. He knows that that can't be true, because at that distance, those radio waves, if they went just straight, didn't curve around the Earth, he wouldn't be able to receive them at that distance, and yet he was. So he knew there was something going on here. So he's getting these longer and longer distances, 21 miles across the English Channel, for example. That was very, very big technologically and symbolically. So he keeps on making these advancements step by step. And he did not have the support of his father. He knew how to keep a grudge. That's one thing he really knew. He didn't have the support of his father, and for that reason, never attended his father's funeral. When the old man passed away, he didn't go. But he did have the support of his mom, and as you can see, a formidable woman. And the interesting thing is, she wasn't Italian, she was Irish. She is, or was, the heiress to the Jameson whiskey fortune. So unusual for the time. She had her own independent finances. And she said, my son, I love you so much. You're such a beautiful boy. I believe in what you're doing. Here's my credit card. Go live with me. And everything. Well, of course, there was no credit card. There's no radio store. There's no nothing. Building it from scratch, step by step. She believed in him, and without that, probably wouldn't have gone very much further than it did. But again, he's getting more and more mileage. He's getting 1,000 miles. If he's getting 1,000 miles, why not 3,000 miles? Why not across the ocean? Why not across the Atlantic? And the idea starts to formulate in his mind. Because at that point, if you wanted to send a message, a telegraphic message, from one continent to the other. There's only one way to do it, and that was by the undersea cables. And that's a whole other wonderful saga of how that was done, and intrigue and sabotage and technology and travail to get the undersea cables working. But once they had them working, at tremendous expense, they had a monopoly. You want to send that telegram to England? Fine. Here, you know, it's going to cost you for that. Well, he says, no, I can do it. I can do it by, I bet I can do it by wireless, and I can undercut these cable guys. So that's what he's betting at this point. And here is the giant transmitting station that he built in Poldhu, in England, on the coast of Cornwall, right on the coast. Now, anybody who's into any kind of construction at all, you look at this, right on the coast, in the teeth of the Atlantic storms. And I mean, and these are all connected by triads all up at the top. What do you think is going to happen here? This is, you know, he's got a tremendously large transmitter in this building, but look at this antenna, and yeah, for sure, that's what happens. No doubt about it. Little short maybe on the structural design on the antenna. But this was part of his great test. He was setting this up because he's now going to go to North America, set up a receiving station, which was already built by his company. He bet his reputation, his fortune, his company on this idea that he was able to do it. So this is going to be the transmitting end. They rebuilt it, obviously, with a different antenna system. And he then, with his long-suffering assistant, George Kemp, they take off, head across the ocean, go to North America, to the closest point, Newfoundland, right? So that's where they go, in December. So, and there they are. Great mustaches, but they're freezing, they're freezing. And again, the station that they had built to receive, very similar to the one to the transmitting station we just saw, same fate. The antenna is down, it's gone. What's he going to do? Everything is invested in this now. You go to St. John's, Newfoundland, and here's this hill with a building on top of it outside of town. And very graciously, he has given permission, he and his team, to go up there and see if they can set up their receiving equipment. They got no other choice. They got to give this a try. And here you see, here's George Kemp. And here is this wicker basket, which is important. And here behind them is a kite. So in the wicker basket is a balloon. So the idea is they're going to inflate that balloon, attach a wire to it, send that aloft, and they're going to use that as their receiving antenna. So they do that, send it aloft into the gale, never saw that balloon again. Just downwind, who knows where that thing went, gone. But they've got the kite. So, okay, we're going to give the kite. And if you read the contemporary articles about Marconi and all the other stuff, they say he was a fanatic kite flyer too. So, okay, we believe that. And anyway, here they are trying to get this thing aloft. Right? You can see in this how they're struggling with this to get this thing aloft on the top of this Signal Hill, now called Signal Hill, up above St. John's, in the middle of the center. Well, they do. They get this up, and it stays. It doesn't. They've got it. It's working. But it's one wire where they were originally had a tremendously large receiving antenna, so they're operating at a tremendous deficit. Meanwhile, back in Poldhu, the instructions are just keep sending this letter S, 3 dots, right? Continuously, just keep sending. So they do that. And he's going to see if he can hear it across the ocean. And yeah.
What is the date of it?
1901, thank you, 1901. So here he is, sitting there, no smiling. And he's got his apparatus here. And this is by our lights, these days very, very primitive, of course, but it's cutting edge then, which is really what counts. And what he's using as a receiving element, a detector, a radio wave detector, is this thing called a coherer. And here's kind of a schematic drawing of it. 2 brass plugs, some iron fine, not iron, but copper, and very silvery, with great debate on what the filings had to be to work best. And if it's impressed by a wireless signal, those filings cohere is the name, and it rings a bell or prints on a tape, on a paper tape. So, okay, that's what he's got. And this is the one that I have, which is a reproduction, but you see, maybe you get a better idea of what this thing looks like. Now, by our point of view today, this is about as sensitive as a brick. I mean, how they ever got any results out of this thing is astounding to us, and yet they did, as the art evolved over decades after this. On ship to shore and other circuits, they went thousands of miles with this kind of stuff. And remember, there's no amplification here. This is just what you're getting, what you're able to catch the radio waves as they go overhead, snatch them out of the air with your antenna, and impress them across this thing. So, okay, so there they are. The main thing in those days was, as the dots and dashes of Morse code came in, it was printed on a paper tape. You didn't actually listen to it. You printed on a paper tape. That was good for 2 things. The main thing is that you could prove that you had received that signal. So you've got it right there. You can see it visually. Nothing's happening. His tape anchor, silent. No 3 dots, no nothing. Starting to spread a little bit. And he whips out his modified earphone here. This is what he decided to use instead of the paper tape. He's holding that up to his ear, listening for those 3 dots. And he then hands it to George Kemp and says, "Mr. Kemp, do you hear anything?" Put yourself in the place of poor George Kemp. He's freezing, he's thinking of a hot meal, a warm fire at the pub down in town, and getting to bed. So what's he gonna say? Yes, I hear those 3 dots. Well, who knows? Nobody knows, but I do know that you can start a fight to this day in a radioman's bar by saying he did or he didn't share those 3 dots. It doesn't make any difference what side you take. It's going to be a fight. Of course, we're all geezers now, so it's just going to be arm waving and story. And that's it. But that is a pilot. But it doesn't make, it turns out it makes no difference. Makes no difference because within years, not many years, of that event, Marconi is already building this global network of wireless stations that fulfill his promise and just what he knew he could do. And as you see, here we are. Here's us up here. It says San Francisco, but it's really up here in Marin. And establish 2 stations. You need the transmitter station, which is in Bolinas, 1914. You need gobs of power, an enormously large antenna. And that's just for 1 circuit. And that's all there was, just one, it wasn't multiple circuits. That's what it took. And then the receive site, the ears of the operation at the Marshall site, which is now the conference center there. And that's getting the signal coming back in, and all of that being coordinated over wire lines down into San Francisco. The cable guys go nuts. They say, well, you can't do this. You're undercutting us by 50%. And he said, hey, oh gosh, you sue me. Okay, I'm doing it. What are you going to do? So he makes a success out of just what he was doing. And you can see here that at first the link was out to Hawaii. Later, they could make the link directly across to Asia. But this is the earliest chart that I was able to find showing the network as it evolved. Now here we are finally getting back onto home territory. This is in Bolinas, and here are some guys looking at the ranch. So this is just off Mason Road, right? You're looking in the distance there, Pacific Ocean. Here's some guys, some surveyors, they're taking a look here. And there it is after it's built, right? So this is the spot. And you know, I was, you've attended, many of us have attended lectures and read works by Dewey Livingston, our beloved local historian. He's working in the map room for the county now. So go over there and visit him. And he has, as part of the collection there, the notebooks that, you can see it right there, the notebooks that these guys had. These are the actual surveying notes and as they surveyed for this site. So, there you go. Anyway, so they're building this thing. And you see here, way out on the coast, that's what they call the powerhouse. These days we say powerhouse, we think it's PG&E and generating electricity for lighting and so forth. That's not what it means in this context. This is where the transmitter, the big Marconi transmitter was. And this stuff, this was real Frankenstein stuff at that point. Giant sparks, enormous power, real killer machinery, just great stuff. And to build that, now this stuff had to come from the East Coast around the Marin, San Francisco, and then schooners across the Golden Gate to the wharf here in Bolinas, which they had to reinforce because the stuff was so heavy and so massive to get that done. And you think of all the expense that goes into, we'll see some of the equipment that they had to install, and yet still they were able to undercut the cable folks by 50%. So his business plan was coming to fruition. Now here's some cable, and I believe in a subsequent picture, we will see where this cable was installed. But this is on Mesa Road in Bolinas, leading up to the site, the transmitter site. And as you see, it's a typical thing here. Nothing changes, right? It's 2 guys working, 6 guys standing around watching. And it was so muddy. You know, they don't even both try to use wheels, as you see. It's a sledge here. And I have come across in my readings the narration of folks who went to visit the station, journalists that were going to write a story on it. This was after it had been built and it was in operation. But they chose the rainy season. He said that we practically lost the horses. We just couldn't do it. So it was a tremendous adversarial situation, and yet they made that tremendous investment to get it all working. And this, again, is the transmit site. And here's this building. This is what we said was called the powerhouse, now called Building 1. And you get an idea, an overview of what this looked like. So we are looking, obviously, from the shore side towards the ocean. You see some of these things hanging in there. We'll talk about what we're actually seeing here. You know, this is one of the really rewarding things to people like me who are obsessed with this stuff, is you're seeing some pictures, and maybe you've seen it, you've looked at it a dozen times, but then suddenly it comes into focus. You realize what you're actually seeing here and how it fits into the larger picture. So we're now inside the building. This is the main part of the spark transmitter. It was 230 kilowatts by their measuring of the time. And inside this alloy chamber is a rotary spark gap. So you've got these arms like spokes on a wheel that are rotating, got high voltage coming in from the outside, the flange here where you connect the incoming power to rotate this thing. And even though it's in an alloy chamber, this was so noisy, so loud, that they had this assembly in a separate cork-lined room to try and deaden the noise, but everything we read from the contemporary literature, you could hear it for a while. And by the way, the establishment of the transmitting station in Bolinas is the reason that the town of Bolinas got electricity before any place else on the coast. At the Marconi stations, as they evolved later, they even had to build their own power station on site. Well, if you could avoid that, tremendous cost saving, and they were able to avoid it here by bringing in substation electricity from Alto and Woodacre, the two PG&E substations, to provide them with some redundancy. Anyway, little side thing. And here is how it looked as it was installed. And here is the drive motor. And this is an alternator here that provides the high voltage that actually goes across that rotary spark gap we were talking about. This wonderful wheel, you synchronize what's coming out of the alternator with how the sparks are in the rotary gap. These are liquid-filled fuses. You can believe that we have two of them still in Bolinas, and they're rated at 19,000 volts each. And there's liquid in there, about like, as you can see, about like that. There's kind of a spring thing that's liquid, and it says, send back to factory if the fuse is blown. First of all, you're in a world of hurt if the fuse is blowing, but nevertheless, magnificent things. So you see just part of the size of the hardware that it took to start generating some of this signal. But then what are you going to do with it after you've generated it? There's a lot more to be done. And here's an overview. Here's the main alternator, as we have just seen. Additional stuff looks like a backup here, and we haven't found any actual documentation of the second gap, but they look like twins to me. A nice set of wrenches here, whenever you need to work on it. Everything top notch. Everything really built very, very well. Up above, on the upper deck, so who knows, but that looks to me like the cable that was on that sled that was going up Mesa Road. So here we are trying to get the signal to be what you want it to be on the wavelength that you want, as much as you could do. Very difficult to do that with a spark transmitter, but that's what they were trying to do. And then couple it into the antenna outside. That's the job. And here are the other things. These are the blowers. It was just a tremendous industrial installation to get these signals going. Now here is something. This is where building one would eventually be built. And this photo is not there yet, but this is here. And this, to me, is really a big part of the whole thing, because when I first got out there in the early 70s and really started wandering around. Now, to me, I live an active fantasy life. To me, it's like being out there in Stonehenge or Easter Island or something. There's all these unexplained things in the ground and cement installations. Finally, it starts to kind of coalesce. You get some idea. But here's this thing, and I'm standing on it. And I thought, well, is this a cement wall that has fallen over? What is the deal here? It makes no sense. This angle iron was not there, but the threaded rods were sticking out of the side of it. Finally realized this is the anchor for the multi-wire antenna. We'll see better pictures of it. And so there you are, you're standing right on top of it. And that is still there to this day, along with many other artifacts. Here's this wonderful aerial photograph of the powerhouse. And we see several things here. One of them is that anchor that we were talking about and standing on. And the other things that you see are these lines. That to us was the most significant part, because this is the grounding system. The ground system was as important as the antenna, and the ground conductivity out there is horrible. So they really had to do a lot of work to do that. So every one of these plow wires is a ground wire. And then you see them going out over the cliff to a metal plate in the ocean. So they went to a tremendous amount of work to get a good grip on the earth, as Tesla would say, to get a grip on here. And this is a part of the grounding system, what today we would call a halo ground. So here is a closer look. This is the shore side of the building. And you notice this box here. We think this is no longer on the building. Building exists, but this box is long gone. We think that this is where the output from those coils that we were seeing comes through the wall. And these are the lines that are going out to the antenna, multi-wire antenna. And this is, again, the anchor down there where we were talking about that I was standing on. A little bit closer, and you see these what appear to be telephone poles. This is part of the ground system now. We misinterpreted this for a while. We didn't really understand what this was, but it's part of the ground system we now see. And we see that, again, the anchor, and here are those two poles now. We see now, we understand what they are. There's two of them on this other side as well. And all of these builder shafts here, the contractor shafts, sadly all gone except one. There is one that's still there. So again, back to this photograph and the box and this window. I'll keep that in mind. Holes in the side of the building. The anchor and the two poles. Now back inside. We think that what we're looking at here is the other side of that hole in the building that went into, that was shielded and protected from the weather by that box on the side of the building in Tomales. It seems, we kind of drew the juxtaposition, but all seems to work. And this, we think, is the ground lead that's going out to those poles and to the halo ground. Here's the switchboard that was controlling all of that on the upper deck of the building. And let's see, do we see it here? We see tracks. We see tracks here of the overhead crane, and that still exists. That's about the only thing that's inside the building that remains from there. But here we see where those coils were on the deck, and we see, again, what we think is the feed lines going through the wall. There, right there, what we think. So here now is looking towards the east, and you get an idea of how big the antenna was. There were 9 of the Marconi pattern 300-foot tall towers. These are actually pressed steel, riveted together. And so it was 3 abreast, 3 abreast, 3 abreast, with the wires of the antenna going over the top of them. And this is the insulators. This is where the wires took off from here, went back into the building. And here are string release, the actual mechanical thing that hangs it, keeps the tension on the antenna. Tremendously big installation. And so at each location, there were 2 cottages, each location meaning Molinas and Marshall. There were 2 cottages for the station manager and the station engineer, and the hotel for the passenger employees. Again, first-rate construction. Every one of the Marconi stations was like that. They all had a tennis court, they had wonderful food. And this is, we think of ourselves fairly remote today, but you can imagine what this was like. By the way, the date here is 1914, when the station first, February 1914, when the station first went into operation. Now we transition up to the receive site in Marshall. And here they're using horses instead of mules, and the road was a little bit better. But again, it's the same deal. You just kind of haul this stuff up to get it constructed. And looking from the ocean side, or the bay side, I should say, you see the powerhouse. Now, they did generate power, obviously, here at the receive site, but the demand was so much less for the receivers and the transmitters that we were able to, they were able to generate it on site. And the hotel, which is still unrestored. And I've been through every one of these buildings from basement to attic. And this is very interesting. This was the Marconi, not the Marconi, Synanon main building for a long time. So you see these architectural layers of the various things. And of course, the further back you go, the less you get to see because it's been destroyed or done away with one way or another. But you can still get the idea. Here's the antenna poles, same pattern as the ones in Molinas, lined up on the ridge And I actually went up there with my sighting compass to make sure that I was telling the truth when I said that this was aligned directly to Hawaii. And yeah, sure enough. So this is capturing the signal that comes arcing over the dome of the Earth, finally getting a signal and bringing that down into the receive building here at Marconi. And here you get a little bit better idea. You see these towers here. These are part of what was called the balancing antenna, another fascinating topic only in itself. Because here you've got this incredibly weak signal coming across the ocean, and you've got this tremendous blasting signal coming up from Bolinas, not that far away. So you get that signal from Bolinas and you phase it out, picking it up on this separate antenna, you phase it out to try and block it out so you can hear a weak signal. And we still see artifacts of those. There are wooden poles on some of the ranches that are still there. And the remnants of this tower, the base you can still see, it's still there. And here's the hotel under construction. And here's a guy taking a selfie on the first. And this is the receive building here. This is where it all happened here. And again, I've been through that building, attic to basement, and we have not found a photograph of what it looked like inside. We know what the function was. We'd love to see, and we see what they use at some other stations around the world. We would love to see the inside of that with the equipment in it. So far, I've been unsuccessful in finding that. So, okay, World War I comes and goes. The Marconi Company did a tremendous job in helping the U.S. communicate into the Pacific during World War I. The end of the war came, and Marconi, by that time, the technology had evolved away from the original Marconi spark transmitter to these magnificent machines. These are Alexanderson alternators. Ernst Alexanderson, an electrical and mechanical genius of Sweden. This is actually as they looked inside the Bolinas transmitter site. So the problem was that Marconi was negotiating with the manufacturer, General Electric, for exclusive rights to these. Now, these were the machines that if you were going to be in the business of international communication, this is what you needed. No choice, this is it. And the U.S. government said, it was just about to sign the contract. And the U.S. government said, no, that's not happening. That's not happening. You did a great job for us during World War I. We loved everything that you did. You're done. You're done. We're going to sell us all your assets, no alternators for you, and we're going to establish a new company, Radio Corporation of America, to hold all of these patents, the Marconi patents, the General Electric patents, all of them together. Take over, 1920, they rip out all the Marconi spark transmitters, which were obsolete by that time, and install these magnificent machines. There is one still operating in the world at Ernst Alexanderson's home country in Sweden. Our chief transmitter engineer has traveled to Sweden, has gone to the town of Varberg, has entered the building where the great alternator sits, has approached it and touched the sacred casket. And back, Reverend Way hasn't washed his hands since. This is the level of reverence that we have. I mean, the technology that went into this. So here's a better view of the transmitting gallery in the transmitter station in Bolinas. And you see here's the two alternators, but until all of this other equipment, it's unbelievable what Ernst Alexanderson engineered to make this all work. But that was what was in the transmitter building 1920 on at Bolinas. They were so proud of what they had done. RCA was. They put this plaque on the outside of the building. It says inside this building is 2 antennas and alternators, most fantastic thing in the world. We're so proud of it, RCA 1920. So when I got there in 1972, this plaque was still on the wall outside the building. Go back in 1973, no plaque drawn, just the 4 studs sticking out of the wall. And I said, oh man, you know, I just hope that a collector has taken this and not a scrapper, because then the result, you'll never see it again. Turns out that it was Ivan Nielsen, right, Richard's father, who had taken, an engineer, a highly respected engineer, had taken this, had in fact taken the plaque to preserve it. But I don't know that, so I'm waiting through the 70s, the 80s, the 90s, the 2000s, finally get a call from Museum San Jose. How it got there, we don't know, but they say, look, we've got this thing, we think it's yours, we're tripping over it in the hallway. Would you please, take it's gotta go. So I mean, before they even hung up the phone, I was down there again. And there's a very happy radio. So it's now returned home, and we've had so many of these things happen in that way, where somebody whose father and now grandfather had worked at the station, and they said, you know, the granddad brought this home 40 years ago, I don't know what you want, and of course it's a very important artifact that now finds its way back. So many, many stories like that. Marconi, back to Marconi now. So he's still, even though he's out of the business in the United States, he's still an inventor and experimenter. He's still testing, he's trying stuff. He's looking at, and he's doing it aboard his yacht, the Electra, here. And he has started to get an inkling of very,
Smile.
very bubbly, ebullient. But there he is anyway. He's continuing his work. And still at this point, if he wanted to be in the business of intercontinental communications, gobs of power, enormously large antennas, Alexander's of alternators, all the rest of it. He's starting to get an inkling that maybe there was something going on here, just like Hertz did, you know, what something is taking place we don't know about. He's starting to get an idea that instead of these enormously low frequencies, enormously long wavelengths, that maybe if you use shorter wavelengths, even with less power, which was thought to be useless, again, you know, they say radio waves don't go past the horizon, shortwave is useless, but he's getting the idea, maybe that's not the case. To the extent that he had contracts to build these transoceanic coast stations, and I believe in Australia. And he could very well have fulfilled that contract and said, I did just what I said, it's working, give me my money. But he said, no, I think I better not do that. I'm going to, at my own risk, my company's risk, I'm going to build shortwave stations. And if it doesn't work, it's on me. If it does work, you pay me my money. And as always, you know, he risked his reputation, his company, his fortune. And he was right. And why was that right? Because it turns out, again, we're talking about magic here, it turns out there's an invisible mirror in the sky. Who knew? Who knew? But it's there. There it is. And it turns out that these shortwave signals can bounce off of that and come down thousands of miles away. Nobody knew until these guys, Kennedy and Heaviside, started really looking into this. What can this be? They start bouncing signals and seeing there's only one explanation for that. And it's really not even as straightforward as it seems to show in this diagram. There are various levels. It changes day to night. It changes 11-year cycles. There are all kinds of different propagation modes. My favorite is sporadic E, and it just rings, you know, trippingly on the tongue. But this is shortwave transmission. This is the underlying basis for it. So that was what we call disruptive technology. Suddenly, these magnificent Alexanders and alternators that you had to have if you wanted to be in the business, obsolete, scrambled, they're done. That's why we don't have it And here is one of the first experimental shortwave transmitters built at the Bolinas site. This would have been in building 1. And I just love it that, this is tremendously high voltage here. There's the tubes here and the resonating circuits. What's the protective apparatus here? It's a bar around it. And if you are dumb enough to reach over that bar and you get what you deserve. I mean, please leave me alone. Air ocean, we don't know about that. So this is one of the first experimental ones, call sign KEL. And we're lucky to have this picture. We even have some of the signal reports from this transmitter, and that's when RCA started saying, no, he was right. This is where the future is for intercontinental communication. Shortwave is what we want. And here now, back to that transmitter site in Bolinas, and look at the number of antennas that are there now. Right? Each antenna pointed directly at the city, Hong Kong, Sydney, Singapore.
What year?
Yeah, good question. What year? This is 1930. Sorry, I keep leaving out the dates, but thank you for that. 1930. And so we see, here is building 1, the powerhouse, still out at the coast. And here is building 2, which is where Commonweal now has its offices. And in the 50s, there was an extension built on the back here of building 2, building 2A, which is where all the transmitters are today that we operate and that we restored. But just look at this. I mean, to me, this is like radio porn. You can just if I could just get in a time machine and say, okay, this is great. Now here is some fantastic aerial photos. You get a better view of what the Marconi pattern masts look like, and then you see this over here. And it's a rigger. Hanging out there. I mean, these guys, and I got to meet Jimmy Bourne, who was the chief rigger when I first got there. These guys just fearless, loved heights, loved what they were doing. And we have some of these artifacts at the transmitter site, bosun's chairs, bosun's chairs that you paint masts with, or maybe go up stuff, little board seat and rope. But one of them has wheels on it like those inline skates, but it's at an angle, and I could never figure that out until I saw this picture. So this guy is just sliding up and down the guy wire on this bosun's chair. I mean, you go for it, man, not me. I won't. Receive site, again, 1930, to correspond to that building that we just said at the transmitter site where Commonweal now has its offices. That was the shortwave transmitter building. Here is the shortwave receiving building. This is the one that's at the foot of the Cypress Tree, just off of Sir Francis Drake in the park. Beautiful buildings. In fact, they're restoring it right now. The park is investing a lot of money into preserving this and making it look great again. And this is where we have our receive site for the ship to shore that we were talking about, station KPH, PH from Palace Hotel, right? So you can see a big story there. Maybe we'll get to talk about that another time. But this is where we are active every Saturday for the ship to shore part of it. Beautiful building. But it wasn't built for the ship to shore, it was built for the reception of these transoceanic signals. I took this picture when I got there in 1972, and my mind was just blown. These guys let me in to see what was up in this upstairs room, which is completely copper lined, copper screens. It's what we call Faraday cage, and you've heard about it, just to keep out all of the interference except that little tiny signal that you're trying to get from Sydney or some place around. I mean, I was just blown away. And here are some of the folks who work there. This is Dick Flint. Folks may know who live down in Inverness where I do. He's one of those guys, when Dick Flint, great guy. Some people achieve that, and you can't try to achieve that. It just comes to you Wonderful, wonderful guy. And he put in a large part of this console, and you can just barely see above some of these receivers the city names that they're listening to: Tokyo, Sydney, Guam, all the rest. And to me, that was just unbelievable. And I got there just in the nick of time because 72 was working, 73 was gone. Just hit it just right. Well, those receivers all went to the dump. And oh man. So I get wind of one of them, they're called R3 receivers. Independent, so you've got to have multiple circuits over one receiver. Big deal, really important technology, interesting stuff. Got wind that there was one in Germany. I called the guy up and said, you know, please, you have this? Yeah. Well, put it in a box, put the box on this ship, and I'll send you money. So here it is, being unloaded from the Jeep. And then, so now what you got to do? This is technology that nobody has worked on, nobody can really get. This is not like any other receiver you're going to find. But of course, we've got folks who are just really, really sharp. Took a year for one of our guys, this is his workshop, step by step, bringing it back to life. And then we installed it, and there it is working. So again, like so many things of our project, this is the only place in the world you're going to see this stuff. And we've got two others that are waiting for restoration, and this one is actually, this is working. So it's just trying, and you really, well, I could go on and on, I couldn't restrain myself. So, but here, oddly enough, at the Marconi Conference Center, they had this little exhibit area, and there was this log, a stack of log sheets, and they said, well, this is the log sheet from KPH, the ship to shore. And come on, it's not, I know better than that, give me that thing. So looking through it, and this is actually a transmitter log of a transmitter in Hawaii that is talking to a receiver, just like the one we restored here in San Francisco at that receive site. And you see here, starts to gray out in San Francisco. So we were talking about day to night, like an AM radio, you can hear so much further at night. So it's like that, so it fades out, they go to another frequency. And when I got to the Bolinas transmitter site, I watched them do that as the sun went down. It was like a godlike, these guys, bam, getting these transmitters off from different frequencies. Fantastic. We got time. So there we go. I'm in that transmitter building at Bolinas. Guys let me in, mine is blown. I said, okay, normally I wouldn't share this bit of intimacy, but it's part of the story. So I said, okay, this is great, I'm loving it, got to use the bathroom. Okay, over there. And of course, it's a beautiful 1930, marble everywhere in there. So I go in there, sitting in the stall, and I wouldn't share this except it's important. And they communicated between the stations using Morse code, the clicker Morse code that you hear in the Western movies, the guy with the green eye shades. And I look up on the wall, there's a Morse code key and a Morse code sounder on the wall in the stall. No such thing as time off. The transmitter's off there. For God's sake, I'll get out there just a minute. Give me 5 minutes. I took the sounder. I have it. But anyway, this shows the circuit from Hawaii to San Francisco. It's a wonderful thing to be preserved. This is the transmitter gallery at Bolinas as we found it, except this is 100 times cleaner than when we found it. And by the way, this is all National Park Service stuff. That's the landmark, that's why it's preserved. When we made our proposal in 1999 that this needed to be preserved, and we were the guys to do it, my co-founder and I, and they look across the table at us, Don Newbaker and Newmarket and Senior Staff, and I realized they're not looking at this wonderful proposal that we have made, pictures with circles and arrows on the front, and paragraph on the back saying what each one is. And they're not looking at that, they're looking at us in the eyeballs and saying, okay, how crazy are these two guys? I mean, are we gonna have a 5150 situation down the line? Or are they gonna stick with it? You know, where they found the vision and the trust to say, yeah, go ahead and give us the keys on top of it. And we've gone through various iterations of several different superintendents now, and we worry that each time someone new comes on board, they're gonna say, you have old guys doing what? With how much voltage? No, there's kind of, yeah. So far that hasn't, you know, we've had tremendous support from the park. So anyway, this is what it looks like. There's various vintages of transmitters here. One of them was the most complex, was used in the point-to-point transoceanic service, technically complex, physically deteriorated. Here's just one shot of many that we have of what the salt air in that building had done. And here it is after it's restored, and step after step after step. Why these folks from Hewlett-Packard, who were part of our group, decided to take that on, they say now, if we knew what it was going to be, we never. It took them 3 years and 3,000 hours. And here's the interior of the two final tubes. And they had to actually re-machine the deck because it had been corroded right through. Anyway, and now it's like, it's unbelievable here. So once the point-to-point ended in '73, transferred over to ship-to-shore Morse code. So we restored it in that configuration. Here's Steve Bizarre. He's the guy who restored that receiver that we saw. He's tuning this thing up. And here's Cecily Muldoon, right? It's 2013 superintendent of the park. Great supportive, wonderful person. And so she's going to turn the thing on now for the first time. And here you see me. You see the thought bubble up there? Oh my God, don't let this thing catch on fire. But of course, there was no chance of that because the restoration was meticulous and perfect. So this is now on the air, fully operational. And this was the transmitter that talked out to Guam, but it's now on a frequency that talks again out into the South Pacific, so when we work ships out in that area. This is the transmitter they're listening to. Yeah, so this is it's just tremendous. This thing, we had the great fortune of having a guy with us when that money button was pressed, who had actually worked on this very transmitter when it was last functional at the Williams transmitter site. A tremendous honor too. And of course, when we run across people like that, it's really too bad for them because I mean, we just sit there and grill them like an onion. I mean, we just anything you can tell us, with more and more, tell us more and more. Well, this is part of what you would get to see if you join us at the transmitter site. March 15th, I believe, is the date for the tour that we've set up. It's going to be limited in the number of people that can go just because of the space and what we have available. And I think we have come to an agreement that if you want to sign up for that, you can do it through the Regional History Museum website. Now it'll be forwarded to me. So it's a dozen folks, and we can do another tour, you know, if that's needed. And I think already 3 slots are filled. So if you have any interest in that, it's going to be on March 15th. Starting at 12 noon, and I'll be there to do that for you. Well, I thank you for your kind attention.
So he was self-funded from his mom, like up to 1914 or more, but when did he start getting grants and government stuff?
He didn't really, I'm not an expert on this, but, sorry, stand to be corrected for folks who know more. But he formed very early on, didn't get grants, he formed a company that was going to sell apparatus to ships at sea and was going to build these stations around the world, charge money for the service, for the message service, make his money that way. And that's how he did that. So it wasn't, there were government contracts, and one of the things he didn't sell the stuff to the ships, he leased it. Genius. All the stuff belonged to him, including the radio officer who worked it this 18, 19-year-old kid who was sitting there. So that was basically very broad terms what the business plan was. Sir?
When you say you're up and broadcasting now, what do you do?
When we are on the air now, what are we broadcasting? We're sticklers for historic accuracy. It is a serious project of historic preservation. So the station that we have restored is the ship-to-shore part of it, like I mentioned, KPH Buffalo right here, check it out. And so we do it just as they did. We listen for calls from ships at sea. How many of them still have Morse? None. Except some. There are still some. And I've had the pleasure of working with them. And then we also send out press, which the station did, copied aboard the steamers, printed, and put in the staterooms overnight. And also weather, high seas weather. Do that just as it was originally done. And when I was there on my own, you get busy with visitors, and I didn't send the weather. And, who's listening? So I found out who's listening. The emails, you said you were going to send the weather. You didn't send the weather. I was serious about what? So it's like that. I did have the very wonderful opportunity of working ships off Africa, off Antarctica, even though the station was built. This is again the ship-to-shore station, was built to service ships in the Pacific and Indian Ocean. But the station gets out all over the world, and we have listeners all around the world. Believe it or not, music of Morse code, that's what they've got on the air, that's what they got on their receivers, working in their shops. So that's what's out there. Yes, ma'am.
Are you concerned about funding cuts with the federal government?
Always concerned about funding cuts. Yeah, of course. The Park Service, again, has been tremendous supporters. We do our own fundraising. We're completely inept at it, admitted, but we're also very stingy. So it does tend to pile up. And we have depended on the Park Service for major funding. I'm talking $100,000 or more projects that we administer. I have no idea what's going to happen with that and what's going to happen with the people, the rangers and the personnel who are friends and dear to our hearts. Like so many other people in the country who are working on that. But we have no idea what's going to happen. Oh, anyway.
When you transmit, how long do you transmit for?
When we transmit, how long do we transmit for? We start at 10 o'clock in the morning with the press, and we continue to about 5 p.m. And this is on Saturdays only. So that's the full broadcast day, as it works. Yes?
Marconi, back to that, and the short wave and the long wave to short wave. Did he got wealthy? Did he make money off the short wave? Where was his,
Yeah,
where did he end up?
He did. In spite of enormous setbacks, we've only described one of them that happened here in the United States. He had some patent decisions that went against him, he had some other things, but yes, I think it's fair to say that he did die comfortably wealthy. Yes. In the corner.
The distance between the balloon site and the Marconi site, why was that
Oh,
the
yeah.
right distance?
Yeah, why the distance between the two sites? Because the transmitter is to bridge the gap over the oceans, has to be significantly powerful. And yet you're trying to receive a very weak signal at the receive site. So you want to separate those out as much as you can, because otherwise it's like trying to hear a whisper in a room full of people holler. You can't do it. So they physically separated them. And there were some of the less extensive stations that operated co-located, but that's a compromise. The station was separate for that reason. Yes? Yes, ma'am.
You mentioned that that some of the sites were able to obtain enough power from PG&E via Woodacre substation and so forth. That seems a lot of power that they would have had available then. But so I'm curious about that, but how did the locally generated power get generated? What was the source of the fuel?
That would apply to the receive site up in Marshall, because that's where it was locally generated. And the answer is we don't know. We've not been able to find interior photographs of the powerhouse there. So I can make assumptions and guesses, but that's really not the business of historical accuracy, it's a guess. And we don't know. Yes?
I was wondering about the change of location from Marconi on the bay to KPH out on the ocean. And I seem to remember, and I think it might have been Dick Flint who told me, that had something to do with the salt marshes of the bay and the long legs.
Yeah, the actual reason was that, as we saw from the photographs of the Bolinas site, after the shortwave revolution had taken place, how many antennas there were. There just wasn't space in Bolinas, rather in Marshall. There was space, let me get this straight, there was space in Bolinas for these extra antennas. There was not space at Marshall. So a guy named Harold Beveridge, Dr. H.H. Beveridge, inventor of the Beveridge antenna, I know you're all familiar with the Beveridge antenna, he selected the site out at Point Reyes because, not so much because of salt marsh, we didn't really have it there, but because it's right next to the ocean and there was enough flat land for all of these antennas. And in the receive site, there were 3 antennas pointed at each individual city, so you needed a tremendous amount of land. And I actually got to meet Dr. Harold Beveridge. He said, "You can call me Bev." I said, "There's no way." But so, what a gentleman spent the afternoon in his study on Long Island, and then what that meant. But anyway, that's the answer. It was noted, so yes.
So the signals, what were they mostly emergency, or what was the signal?
Well, yeah, what were the signals? Again, we're talking about ship-to-shore part of it. And they were messages of maritime commerce. They were business messages because it was expensive.
They would be received and then go to whoever they on the shore that were.
Yeah, exactly. So here you are, a businessman, and you want to send a message to your ship. You're a ship owner or a ship charter. You want to send a message to your ship. And so you go into the office, the RCA office in San Francisco, or you could bring a little buzzer. We still have them. The messenger would come to your office and pick up your message. Goes to the central radio office in San Francisco, goes up to, depending on the era, but let's just say the one with the receive site that's at Point Reyes, goes up to Point Reyes, goes in the message rack, ship calls, "Do you have anything for me?" I mean, look, yes, here it is. Send it to the guy. "Do you have anything for us?" "Yes." Send it, give it, because every word is money. So, yes, yeah, I'm ready.
That's Morse code.
It's all Morse code. Yeah, it's all Morse code. And so it's all business. There's no fooling around. Time is money. And you can get away with anything if you're an operator on a ship. You can send slowly, you can send fast, you can send like you're drunk, you can send like you're feeding 2 spoons together. But shoreside, that's where the real skilled operators were. So you had to be able to say, yes, don't worry. Fast, good, fine. Slow, good, I've got patience. And because, again, revenue for the company. And there was a little bit of banter that took place at the end. And you would say to the ship, 73, meaning best regards, OM, old man, everybody is old man, no. First female radio operator at KPH, Denise Stoops, who's still living in Bolinas, she would say 73, slant bar, 88. 88 means love and kisses. Okay, 73, 88, all that. Did you say 88? Yes. Are you a YL, right, young lady? Yes. And bouquets start arriving, and sometimes the radio officers start arriving. So, but yes, that's how it was almost. Yeah. And man, I used to say, hey, the typical swellhead, I thought I was pretty good on the Morse code key. And, I mean, I am pretty good. I'm the chief operator at the station, but I started meeting when we first started the folks who had been there as their careers, not as a hobby, but as their profession. And then I start realizing how I have a lot more to learn here. And it's not just a matter of going fast, it's finesse and style. And you can tell who's sending. You know the person, you know who it is at the other end. That's why we still use mechanical keys, so you can put a little style, a little finesse, a little signature into the way you're sending voice. All right, I know you didn't ask about that, but yes, please.
How would you do that? How would you put style and finesse in?
Well, it's called a swing. You know, there's a Lake Erie swing, there's a Gulf Coast swing, and you extend out your dashes a little bit, but not too much, and you do a little bit of this over here. You know, it's like improvising, you know. It's kind of like that, yeah. Yes.
What period of time had the highest number of employment out there? I always wondered that.
Yeah, I'm not sure about numerical employment. I guess it must have been when both the point-to-point and the ship-to-shore were operating simultaneously. So let's say 1920 up to 1973, because they needed folks to operate both services. Peak of traffic was during the Vietnam War, where the U.S. was getting underway. Every ship that was in the mothball fleet, the Liberty ships, the Victory ships, all of their World War II radio equipment still on board. Who are you going to call? Well, there's a station that's on here, that's who you call. That's where the big volume of traffic was, volume of radio. We're done. No, we're not done. Wait. Sorry, 5 minutes back.
Thank you very much. It's not a question. Really enriched in your topic with Indian history of West Marin. My friend actually, David, got me here all the way from Berkeley. I come from India.
Wonderful. Thank you for making the time and coming.
Just, by destiny, I was friend to great grandson of Jagadish Chandra Bose from India, who actually started the Kohela, during the same time when Marconi was doing the experiment with, the radio. Based on this Kohela, actually, he more advanced work with Canada communication. And it's a very sad story that he could not do the getting of the, he was one of the pioneers, I would say, of the radio system. It's a very sad story, so I was always inspired. So I was going to one of his great grandsons. That's how I didn't really knew about this system. So, but I'm dedicated to your lecture and it's great to know about Marconi from
Wonderful. And, yeah, there were many pioneers. And we had, of course, if you were in Russia, the inventor of radio was Popov. And we had, early days, some pretty large Russian women coming to visit. And I said, you know who the inventor of radio was? And I said, yes. It was Popov. Oh, Popov, they're like lifting me off. Many workers.
On the issue of Kent, which way were you leaning? Did he hear it?
No, man. No. But I don't know. He was a faithful worker of Marconi. So, who knows? But I know it was me. I know where I'd be going to the pub. So, I think we're good. Thank you so much.